Hi, welcome to Numerical Analysis Methods. Today we're going to go through direct methods for solving linear systems, specifically the Gaussian method without pivoting. So what I'm going to do is show you what system of equations are, show you what matrices and vectors are, and then we'll learn how to apply certain operations to matrices, and then explain what the Gaussian elimination method is, how to get it by doing an example. So let's start with systems of equations. A simple equation is just an addition of certain variables and constants that gives us an answer. So for example, if we had like x1, x2, and x3 with constants, let's say b, c, d, this on itself is an equation. So now if you had another set of equations, ex1, fx2, let's say fx2 and gx3, b hx1, gx2, and h. So this is j x3. So let's say you had a set of equations where your variables are the same, but the relationship between the constants and the answer and the variables are different. Meaning you have a system where there are certain inputs, x1, x2, x3, but you have different results based on the certain inputs you put in. Then what you get at the end of the day is a system of equations. So what's important to note in a system of equations is that the variables are all the same. They give the same answer. And that's why it's called a system of equations. The only difference between these equations mostly would be the constants and the answers. Let's say you had this example of system of equations with the same constants. What you can do is break them down into a matrix. Now, a matrix is just a block, I would say, with constants in them. It's got different constants within the blocks, say like so. And each column represents the constants of the variable. So these constants here, for example, would represent x1. These constants here would represent x2. And these constants here would represent the constants for x3. And a vector, on the other hand, is a one-dimensional matrix. This matrix is a 3 by 3 matrix. It's a two-dimensional matrix though, because it has a column and a row. But compared to the vector, the vector only has one column. So when it has one column, it's called a vector, and it's usually represented by a little notation on top of a variable like so. So if you see that, or you see a hat like that, this represents a vector. whereas a matrix can just be represented by a letter on its own. So in terms of systems of equations and solving systems of equations, you'd want to break this down, something like this down, into a matrix augmented with a vector. I mean, the matrix and the vector together. So again, let me use this one for example. It's got 3 by 3 variables. And you can put the solution as a vector. So what we need to do to put it in a matrix form, to put the variables in a matrix form, is to only concentrate on the constants. So the constants here are B, C, D, E, F, G, H, I, J. So I'll write them as is: B, C, D, E, F, G, H, I, J. So it just follows this order. And for the variables, same thing, but it's in vector form. Just write A, B, C. In an example, it'll be numeric, not just letters like I did here, but we'll get into that. So it has to be in an augmented form, and what that means is simply you take the matrix being B, E, H, C, F, I, D, G, J. You take the matrix, and instead of closing the matrix, you put a dotted line in between them. Now that dotted line represents that equal to sign that we had in the previous case, and we just write down the answers. Now this is a augmented matrix. It's just your matrix and your vector put together, and this will allow us to solve the system of equations in the next example. Another thing I want to explain is how to apply certain operations to a system of equations. So let's say you had this in this form, and you wanted to make B 2 times its value. You know that in an equation, if you multiply the left hand side of the equation, you also multiply the right hand side of the equation. So let's say this is equation 1, and this is equation 2, and this is equation 3. If you wanted to transform this equation, this part, to this B, this variable, to 2 times its value, 2b, then you'd have to multiply that and that and that. Because let's go back to this. This is our original equation. So 2a basically equals 2b plus 2c plus 2d, because what you do on the left hand side, you do on the right hand side. So going back to this, we'll end up with 2c, 2d, 2a, EF, GA. The rest just stay the same. And as you can see, that means that we just transformed this equation 1 to 2 times equation 1. And that's the operation that you can apply on the matrix. You can multiply a row by any value that is not a 0 and get a new equation. You could also, let's say you wanted to subtract this equation by that equation. So that means that E3 in this case will become E3 minus E2. What that simply means is that you can take this value here, subtract it by the value before it. You can take this value here, subtract it by that value before it, that value there, and subtract it by that value, this value subtracted by that value. And that gives us new possible answers over there. Another thing you can do is change two rows. Like instead of having equation 2 here, you can have equation 3 at the bottom. I hope that is self-explanatory, which means that E can come down here, H minus E can go up there, but you have to switch the entire row and switch the entire row back up. So let me just write down an example so we can get into the examples.